Power company sells you energy. And in physics, once again, we calculate energy or power. It's work divided by time. Energy is the ability to do work. It's really energy divided by time. How much energy are you using and how long? That's power. So the physics unit, once again, is named for Watt, James Watt, who helped define this. If you're talking about mechanical power, they use horsepower, which is used for things like cars and vehicles. They're going to make you change units on the AP exam if they end up giving you guys the full test. There will be an FRQ that is math-based, and almost every single year, part of that math question requires you to convert units. Factor labeling, just like in chemistry. So I want to show you some of that today because watts, just like joules, watts are pretty small. And if you're measuring at your house how much electricity you're using and you get a monthly electric bill, you're not going to get a bill in watts. You're going to get a bill in kilowatts, 1,000 watts, okay? I don't know if you've seen this before. When I was your age, I actually, and I'm pretty good in math and science, but I struggled with the metric system. For some reason, it just didn't click with me. And when I got to college, I was struggling in chemistry, and one of the tutors showed me the metric staircase, which I had never seen before. And all of a sudden, everything made total sense. So I know some of you are very good at this kind of stuff. I'm going to take some baby steps here and real quick show you guys the metric staircase. So right in the middle is what we call our base unit. And this works for if we wanted to calculate meters to kilometers, if we wanted to do grams to milligrams, liters to milliliters. This works for all of those, okay? Because these are just our prefixes, which indicate times 10, times 100, times 1,000, 1/10, 1/100th, 1,000th, and so on. Okay, so our base unit goes right here. That's where we would put watts. Now in this problem, I have asked you to take 1,000 watts and turn it into kilowatts. So watch what happens here. I am going to go 1, 2, 3 steps up to kilo. So I moved 3 decimals to the left. See how easy that is? And so if my decimal was right here, 1,000.0, I would move 1, 2, 3, and we see that 1,000 watts equals 1.0 kilowatts. And there you go. 1,000 watts equals 1.0. I move my decimal 3 places to the left. If you move down the stairs, you move your decimal to the right, and you add zeros if you need to. Now, we also need to very quickly touch on scientific notation. So we can remember, write this 1.0 kilowatts or 1,000 watts is the same thing as 1 times 10 to the third watts. Okay, anytime we have zeros, we count up our decimal places. Remember, in scientific notation, you're only supposed to use one integer in front of the decimal. So if I wrote this out completely, it would be 1.0 times 10 to the third. That's fine if you're going up to kilowatts, but if we're measuring the energy usage for Indianapolis, how much does our power plant downtown create and produce? Well, kilowatts isn't going to handle that. So we're going to have to go even bigger. And that's where we get into something called a megawatt. And here you can see a megawatt, 1 MW, capital M, is 10 to the 6th watts. Now, there's a shortcut. If you were going from kilowatts to megawatts, that's 3 steps, right? That's 10 to the third. 1 megawatt is 10 to the third kilowatts. But as long as you know your base unit, you're good. Mega is 10 to the 6th, or 1,000,000 watts. 6 zeros. All right, if we keep going, if we are measuring the energy production of the entire country, well, even megawatts isn't going to cut it. And so we can go exponential here. Another 3 steps takes us to the prefix giga, and we've now gone from 1,000,000 watts to 1,000,000,000 watts in just 3 steps. All right, so we go from 1 watt to 1,000, 1,000,000, and 1,000,000,000, just like that. Metric staircase, quick, easy way to do conversions. They want you to show work on the AP exam. They want you to show factor labeling. So you can use the metric staircase to double check your answer, but I think they still want you to show this kind of work. Now we could use the metric staircase and get the answer in seconds. I'm going to move my decimal place 3 to the left. I'm going up 3 steps. 1, 2, 3. My answer is 950 kilowatts. I didn't have to do any work. But here's how we do factor labeling. All right, first step is I need to get rid of watts as my unit. To do that, I'm going to put watts on my denominator. Those now cancel, okay? Now, the unit I'm trying to get to is kilowatts. And from the metric staircase, we know that there are 1,000 watts in 1 kilowatt. That's what kilo means. But here's another little trick. Which one of these is bigger, watts or kilowatts? Well, a kilowatt's bigger. So whichever number is bigger, you always assign that the value of 1. And then you look at your prefix, and kilo once again means 1,000, so that goes on the bottom. And there I got my conversion factor following some simple rules. I want watts to cancel. I want to end up with kilowatts, and I know that kilowatts is bigger, so it gets the 1. So there's my answer, right? 3 zeros cancel out with the denominator, 950 kilowatts. Awesome, we solved that problem using a conversion factor. It's going to be to your advantage when we get into big numbers to use scientific notation. This is standard notation. So if I wanted to turn 950 kilowatts into scientific notation, remember I can only have 1 integer in front of the decimal. And so I would have to move my decimal place 2 times to the left. So my scientific notation is 9.5 times 10 to the second kilowatts. When they bill you your electric for the month, they keep track of how many kilowatt hours you use. And so I want you to recognize this unit. K, capital W, H stands for kilowatt hours. And in the old school electric meters, you can see these little dials literally spin around as you're using electricity. They've come around to my house and mine's all digital now. The outside meter gives a digital reading, but it still references kilowatt hours. If you've never looked at your electric meter or your gas meter, go out there and check it out. Tell your parents that's what you're doing. They'll think you're weird. If you don't even know where it's at, ask mom or dad. They might know. Ask them if they get a printed electric bill or gas bill. Ask them to see it, because I'm actually going to show you one next week, and we're going to calculate some things. If you've never seen your bill, see what that's like. Someday you're going to own a house, and you're going to pay the bills, and you'll now know what all this means. Here's an example of what a kilowatt hour really is. It is the amount of electricity that is used by the consumer in your home if you were going to use a 10-watt bulb for 100 hours. Watts times hours, oh, that's 1,000 watts in an hour. So that is 1 kilowatt hour. Kilowatt is 1,000 watts. Okay, here is a 10-watt bulb. If you go to the store and buy new bulbs, if you buy an LED, which is way more energy efficient, they're going to have some numbers on here. Incandescent bulbs used to range between 60, 100, 150, depending on how bright you wanted them. That's called the lumens. You can see the brightness of a 60-watt bulb. It has a luminosity of about 800. Well, because LEDs are so much more efficient, we can get 800 lumens with only 10 watts now. And that's going to save you money because you're not going to get to 1,000 as quickly. We used to get to 1,000 way faster when it was a 60-watt bulb. You can run this bulb now for $1.20 a year. That would used to be the monthly cost. So we are saving a lot of money. And this bulb is, the LEDs are expected to last up to 22 years. Huge improvements in light bulb technology. We talked about how we burn coal or gas to heat up water to make electricity with a turbine and a generator. So we can now calculate how much power a power plant can make and how much electricity that is. So the capacity, that's when the power plant is running at full steam. Capacity of a coal power plant is 10 megawatts per hour. If operating at full capacity for 5,000 hours per year, how many kilowatts hours of electricity did they make in that year? The first thing I want to do, since my final answer, that's what I want to know, how many kilowatt hours? So I know I'm going to have to change megawatts into kilowatts. So the very first thing I'm going to do is a unit conversion. And let's follow those steps from before. I want megawatts to cancel. So I put it on the bottom. Now, what am I trying to get? I'm trying to get kilowatts. And if you knew the shortcut, you could go directly to kilowatts, 10 to the third. But the unit factor I gave you is watts. We know that 1 megawatt, it's bigger, it's the 1 megawatt is 10 to the 6th watts. That was the conversion factor I previously gave you. Megawatts cancels out. Now, I don't want watts. That's what I'm left with. I want kilowatts. So I'm going to do a second unit conversion. Watts now cancels out on the bottom. Kilowatts goes on top, and we just use this one, right? Kilowatt is bigger, it gets the 1. And now we have 10 to the third on the bottom. Okay, that gave me what I wanted. I now have put 10 megawatts into kilowatts. And what I get is 10 times 10 to the third. Remember, when we multiply, add the exponents, if we divide 10 to the 6 divided by 10 to the third, they get subtracted. So on the top, we end up with 10 to the third. Now, that is not proper scientific notation, is it? Because I've got 2 digits in front of the decimal. So I'm going to change that one more time. Move my decimal one more time to the left. So now it becomes 1 times 10 to the 4th kilowatts. But I'm not done, because that would be for 1 hour. And now I need to know that I'm using this for 5,000 hours a year. So I'm going to take 1 times 10 to the 4th times 5,000 hours. And I get 5,000 times 10 to the 4th. And so I'm going to, once again, use scientific notation. I'm going to move my decimal 3 to the left. Those get added to the exponent. So my answer is 5.0 times 10 to the 7th. I've done these problems for years. And I always show kids, and they're like, oh yeah, I got it, no problem. And the second that I give it out as an assignment, I see that half the class has no clue what they're doing. So once again, we will do some practice with this next week. Go back to these examples, all right? Go walk it through baby steps if you need to. And since we're virtual right now, reach out for help. Message me and say, I really don't get that problem. Can you go over that with me one-on-one at some point? And we'll do it. Once again, you could solve this lots of other ways. You could have immediately just multiplied 10 megawatts times 5,000 hours, right? So that's 50,000 megawatt hours, and then change it into kilowatt hours. To me, it's easier to change it before you multiply. A plant costs $4 million to build. The population of the town using the plant is 4,000 people. Each person in that town uses 400 kilowatt hours per year, all their electricity needs. And when they get their electric bill, each kilowatt hour costs 25 cents. That's actually expensive. We have very cheap power in Indiana. We average around 10 to 12 cents a kilowatt hour. We need to know how much money the power plant is getting each year from the people. So if there's 4,000 people, and they're each using 400 kilowatt hours, and each of those costs 25 cents, let's just multiply all that together. 4,000 people, 400 kilowatt hours per year per person. Oh, look, people just canceled out. People in person, gone. And then it's 25 cents per kilowatt hour. Okay, kilowatt hour just canceled out. So that's going to leave us with money per year. So the people are paying $400,000 a year to the power plant. The power plant cost $4 million. Divide that by 400,000 a year. Cross off a whole bunch of zeros. And it's going to take them about 10 years. Some of our power plants are 50, 60 years old. You think those people are making money? They're making a lot of money. Energy sector, big cash. You want to go into environmental science? Go work for the energy company. we'll stop there today. We will do more next week because I could tell you just love this. It's very exciting. Have an amazing weekend. You guys are the best. Bye-bye.